Hello, I'm Kiran Kumar from Nature of Physics. Today topic is most important concept from the current electricity. Kirchoff first law, that is current law, Kirchoff second law, that is voltage law, and Wheatstone bridge. See student, first Kirchoff current law. According to the Kirchoff current law, algebraic sum of all the current meeting at any junction is equal to 0. Sigma I is equal to 0. See, current toward the junction is I1, I2 and I3 considering. Current away from the junction is I4 and I5 considering student. So, the sum of the current flowing into the junction is equal to the sum of the current flowing out of the same junction. According to this, the sum of the current flowing into the junction is I1, I2 and I3 represented clearly here, and current away from the junction, sum of the current flowing out of the same junction is I4 and I5. See student, I1 plus I2 plus I3 is equal to I4 plus I5, and current toward the junction is positive, that is I1, I2, I3 is positive. Current away from the junction is negative, that is I4 and I5 is a negative student. But finally, algebraic sum of the current meeting at any junction is equal to 0. Sigma I is equal to 0, where I is equal to I1 plus I2 plus I3 minus I4 and minus I5. Okay, and Kirchoff first law obey the law of conservation of charge, that is Kirchoff current law is based on the law of conservation of charge. And next one is Kirchoff second law, that is voltage law student. Say Kirchoff voltage law, that is second law. In closed circuit, algebraic sum of the potential difference is equal to 0. Sigma V is equal to 0. See, in a closed circuit, algebraic sum of the potential difference is equal to 0, that is equal to sigma V is equal to 0. These Kirchoff first laws and second laws we will use in the Wheatstone bridge to solve this. Okay, and we have a conditions. Before that, Kirchoff voltage law is based on the law of conservation of energy. It obeys the law of conservation of energy. V is equal to W by Q, basic formula for potential. V directly proportional to W. Okay, and there are sign conventions are there for the Kirchoff second law, that is voltage law. See, clearly written 4 conditions. Try to understand here. Here blue color represent a direction is taken anti-clockwise direction in the 4 conditions. See, right side to left side, that is anti-clockwise direction considering here, that is represented clearly in the 4 diagrams. See student, right side to left side, so that we are considering as anti-clockwise direction. Okay, that is sign conventional direction. Okay, and current directions we will consider differently. First one is current direction is from right side to left side, conventional direction also from right side to left side, so that current is taken as a negative current, and the potential difference across the resistance R1, which is equal to V1 is equal to minus I1 into R1. See student, current direction, conventional direction same, that current is taken as negative. The basic formula for potential, V is equal to IR from the Ohm's law. The potential difference across the R1 resistance is V1, clearly represented. So V1 is equal to minus IR1. Actually, according to the Ohm's law, V is equal to IR only, but sign convention applied. So here current direction is negative because of in the direction of sign conventional student. Okay, conventional direction. Comparison with the first one, second one, you will get clarity here. Here current direction and conventional direction both are in opposite direction. Conventional direction from the right side to left side, okay, but conventional direction, okay, opposite direction to the current direction. Here current is from left side to right side. See, arrow mark clearly represented. Current and convention both are in opposite in direction. That current is taken as positive. That potential difference across the resistance is taken as V2. That potential V2 is equal to I2 R2, students. See, V2 is equal to I2 R2. Here current is positive. The reason is convention direction and current direction both are in opposite direction. Okay, and next third condition, there is a cell of EMF is E1. So here convention direction is crossing from the negative terminal of the cell to the positive terminal of the cell. We can notice clearly observing. Okay, so in the 4 diagram, conventional direction same taken, student, that is anti-clockwise direction according to the diagram, right side to left side clearly represented. See, student, here conventional direction is crossing from the negative terminal of the cell to the positive terminal of the cell, that is negative terminal of the battery to the positive terminal of the battery we can consider. So here conventional direction ending with the positive terminal of the cell or battery, that's why that EMF is equal positive. Remember that, notice that here conventional direction is ending with the positive terminal of the cell or battery, that's why that EMF is equal to positive. That's why E1 is positive. See, comparing to the third one, in the fourth one, sign convention direction same only, but battery in opposite direction. Comparing to the third one, here sign convention is crossing from the positive terminal to negative terminal, ending with the negative terminal. That EMF is taken as negative. Simply remember, first one is current direction, conventional direction same, that current is taken as negative. Here second diagram, current direction, conventional direction opposite, that current is taken as positive, so that the potential difference across the R1 resistance is V1. That's why here V1 is equal to minus I1 R1. In the second diagram, the potential difference across the resistance R2 is V2, which is equal to I2 R2, student. Clearly we can notice there, current conventional direction same, that current is negative. Current conventional direction opposite, that current is taken as positive. Here conventional direction crossing from the negative terminal to the positive terminal, ending with the positive terminal, that cell EMF is taken as positive. And fourth one is conventional direction is crossing from the positive terminal to negative terminal, that cell EMF is taken as negative because of sign convention ending with the negative terminal of the cell or battery. These are the very useful points to solve this. Next, Wheatstone bridge I am going to explain. Okay, Wheatstone bridge consists of 4 resistors PQRS taken, student. Okay, connected as shown in the figure and clearly represented in the figure, and 4 junctions form, that is A, B, C, D, student. Between the AC, here AC junction, there is a cell or battery of EMF E is connected, and across the B and D, there is a galvanometer is connecting to find the balancing length, balancing point of the Wheatstone bridge. Okay, student, see, clearly represented here PQRS, total 4 resistors considering in the diagram. It forms the 4 junction, student, A, B, C, D. Across the AC junction, battery of EMF E connected, okay, and across the BD, galvanometer is connected, student. Now I am going to explain the derivation. Current is from the battery or cell positive terminal. This is representing current, student. Okay, current toward the junction is equal to current away from the junction from the Kirchoff current law. Current toward the junction is I1, current away from the junction I1 and I2 both considering here. See, student, I1 across the resistance P and I2 across the resistance R. Okay, and next here also representing I1 student, here also representing I2 for better understanding. And then continuation there, at a junction B, current toward the junction is only I1 and current away from the junction is 2 is there. One is galvanometer current is IG and across the Q resistance is I3 considering student. Current toward the junction is I1, away from the junction is IG and I3 clearly represented. Here we can apply Kirchoff first law at the junction B. Okay, and then continuation here, IG here representing current toward the junction, here I2 is there. So at a junction T, toward the junction is IG plus I2 and away from the junction is I4 student, here also representing I4 and this current is representing I student. Okay, so that I3 plus I4 which is equal to I. Okay, this is a closed loop in which two loops we are considering student. First loop is considering this is 1 and this is second loop is considering second student. Here sign convention also we can apply here. According to the sign convention like this, anti-clockwise direction is representing student. See there, anti-clockwise direction for better understanding. Okay, like this representing. See there student. Okay, anti-clockwise direction loop 1 and loop 2. Okay, so here first I am going to apply the Kirchoff first law, that is junction law. Okay, so how many junctions we are considering? B junction and D junction. Across A and C battery is connected, there no need to considering the derivation because of here input and output connections are there across an A and B student, so that junction B and D only considering. So at junction B, current toward the junction is I1, see there clearly, and current away from the junction which is equal to IG plus I3 student. See, current toward the junction I1, away from the junction is IG plus I3. Okay, and next one here at junction D considering student, at junction D current toward the junction is I2 plus IG, both are there student, I2 plus IG clearly we can observe, and away from the junction is only I4 is there, clearly represented Kirchoff first law, current law, that is KCL. Okay, and next one is KVL, Kirchoff voltage law. What is that? Kirchoff voltage law. So Kirchoff second law have the two loops according to the diagram. Okay, so that first one is A B D A B D A, that is representing 1, and second one is C student B C D B, so that is representing loop 2 student. See clearly first I am writing the resistance student. So in the loop how many resistors are there? So for first loop is P resistance is there, and next one is galvanometer resistance is there, and next one is R resistance is there, and second loop has how many resistors student? 3 resistors. One resistance is Q and resistance across the galvanometer is G, and another resistance is S student, clearly representing the current across the P resistance is I1 and galvanometer current is IG, and R resistance current is I2 and Q resistance current is I3, and next galvanometer is IG, and next S resistance current is I4, and sign convention I am going to apply here. See here for first I1 current conventional direction, both are in opposite direction. See student, conventional direction, current direction, both are in opposite direction. See current is I1, conventional direction is anti-clockwise direction. Clearly we can notice here that current is taken as positive. Okay student, and galvanometer current and sign convention both are also in opposite direction, we can clearly observe in the diagram. See student, so that current galvanometer current also positive. Next I2 current, notice that student, I2 current for this conventional direction, current direction both are along the same direction student. Yes, once again repeating, current direction I2, conventional direction both are in the same direction. direction, so that taken as negative. See student, the potential difference across AB is I1P, potential difference across the BD is IGG, and the potential difference across the A and D is minus I2R, clearly represented. Once again repeating, current direction, conventional direction same, that current is taken as negative. Best example is minus I2. Current direction, conventional direction in opposite direction, so that is taken positive. Best example in the loop 1 is I1 and IG, clearly written, which is equal to 0 because of algebraic sum of the potential, okay, in a closed loop is equal to 0. Sigma V is equal to 0 is clearly applied here, okay. And then here I3 current in the second loop, conventional direction, current direction, both are in what direction? You can notice, tell me student, that is in opposite direction. See there, that is I3 is considering as positive student, and galvanometer current IG and conventional direction both are in the same direction. Notice that IG galvanometer current is downward direction, and conventional direction also at the position of galvanometer is downward direction. When current direction, conventional direction both are in the same direction, that current is taken as negative student. And next one is here I4 current and conventional direction both are in the same direction, so that is taken as negative. Noticing again, representing once again, remember that is current direction, conventional direction same, that current is taken as negative. According to the loop 2, IG and conventional direction same, taken negative, and I4 conventional direction same, taken negative, and I3 conventional direction opposite, taken as positive. Now I3Q represent potential difference across the BC junction, minus IGG represent potential difference across the BD, and minus I4 represent potential difference across the DC. Clear information, algebraic sum of the potential in a closed loop is equal to 0. So sigma V is equal to 0 is clearly represented. And then continuation, derivation I am going to apply. There is a balancing condition of a Wheatstone bridge, that is galvanometer current is equal to 0, IG is equal to 0. See the balancing condition for this, the resistors PQRS will be adjusted, so that changing the resistance PQRS, then certain position, certain resistors for PQRS, galvanometer current should be 0, that is Wheatstone bridge is in balancing condition. In the balancing current, no current is flowing through the galvanometer, that's why I1 current is equal to I3 and I2 current is equal to I4. So IG is equal to 0 is replacing in this equation, so that I1 which is equal to, okay, 0 plus I3 student, okay na. And then continuation, next one is here at junction D, that is I2 plus 0 galvanometer current which is equal to I4, okay na. So that I will get here I1 is equal to I3 student, okay, representing here I1 which is equal to I3, that I can write as equation number 1. And next here I2 is equal to I4 student, I2 which is equal to I4, that is representing as equation number 2. Okay student. And then continuation, next we are replacing Ig value in the Kirchoff's second law. So according to this, here Ig is equal to 0 student, 0 into anything 0, so that directly writing there I1 P is equal to I2 R student. And next here I3Q which is equal to I4 yes. So now I can replace this is as equation number 3 and this is equation number 4 student. Okay, wait a second, here I can give clarity for this. See student, okay, so equation 3 and 4. So from this equation, See student, I1P plus galvanometer current is equal to 0, so that 0 minus I2R, which is equal to 0. So that, tell me student, I1P which is equal to I2R. See, I written that only. I1P which is equal to I2R. Okay na? And then continuation, next step here, from this loop 2, that is I3Q, galvanometer current is 0, 0 into anything 0, minus I4S which is equal to 0 student. Okay, minus I4S from LHS side to RHS side, so that I3Q which is equal to I4S. So this is taken as equation number 3. Clearly I1P is equal to I2R, and I3Q which is equal to I4S is taken as equation number 4 student. See, clearly represented. We got total 4 equations, 2 equations from the Kirchoff first law and remaining 2 equations from the Kirchoff second law. So I got I1 is equal to I3 and I2 is equal to I4, and third equation is I1P is equal to I2R, and fourth equation is I3Q is equal to I4S. These 4 equations I got from the condition galvanometer current is equal to 0, that is bridge is in balancing condition. So finally I'm going to replace these values. See student, according to this, here equation 3 divided by 4 writing student, equation 3 that is equal to I1P LHS side, and equation 4 that is I3Q, and RHS side from equation 3 I2R which is equal to I4S student, and this I can write as equation number 5 student. So equation 1 and equation 2 in equation number 5. So equation 1 and 2 in equation 5 replacing, so that I1 by I3 get cancel, I2 by I4 get cancel. I will write that step here clearly. See, notice that here I am replacing I1, okay, P divided by I3. I3 is equal to how much student? I3 is equal to I1. So I1Q which is equal to I2R divided by I4 is equal to how much I got student? I2. So that I2, yes. See now, I1 get cancel and I2 get cancel. I got the value P divided by Q which is equal to R divided by S. This is the answer for the given question student. Okay, so here balancing condition of the Wheatstone bridge is P by Q is equal to R by S, P by Q is equal to R by S. Okay, so that the Wheatstone bridge is in balancing condition. We can solve the problems also based on this. Please do like and subscribe our channel Nature of Physics.